Welcome to Partner Point of View, where we sit down with PTC partners and discuss how together we innovate, collaborate, and unlock power by the convergence of physical and digital worlds.
Hey gang, it's Wolfie again. Welcome back. I'm delighted to have here in the studio the man that Dr. Shomit Ghosh turns to when he wants an expert at Industry X to talk about automotive. Welcome, David Rush, to the studio here in Boston.
Thank you for having us.
And Andy, great to see you again in Austria.
Yes, thanks for having me again. Hi, Dave.
Good to see you.
Nice to see you virtually here.
So, David, I've got to ask, you've been in the auto world for decades now. You started as a baby, obviously, but what has been the dream car that you've ever wanted or owned?
Well, from my accent, you can see I'm originally from England, from Britain. So I'd say always the British cars have a little touch my heart. I know the Italians do a nice job here and there, but I'm kind of an Aston Martin guy, if I'm honest, right?
So you're the James Bond of Industry X.
You've got to keep that thing going together, yeah.
I love it. We were talking with Shomit, and the tension between the need for speed, complexity, and safety is just overwhelming. I'd love to talk with you a little bit about what goes into the sophistication of a vehicle. If I looked at a car maybe in the 1960s, how connected would that car be as compared to maybe the 70s, 80s, or today?
Well, I think as your discussion with Summit, it's all about software today. Back then, if we look at when was the first piece of electronics that went to the vehicle that had software on it, was in the late 60s, 68. And it was actually VW on fuel control. And we had one processor. And in today's vehicle, 100 processors in a premium vehicle. So anywhere between 60, 70 to 100 computers in the vehicle. So the more features and functionality we trying to bring towards the vehicle, the more electronics and the more software we have. So they've become quite complicated, right? It's no longer the days of simple mechanical parts.
When I think about a sophisticated vehicle in my day, when the kids were little, I had a video screen behind my head, and I thought that was pretty snazzy. But today, my car can drive me pretty much anywhere I need it to go. How would I measure the complexity or the connectedness of today's modern vehicle?
It's orders of magnitude different, right? Today, the vehicle has got more software in it than aircraft, and really, think about fighter aircraft and things like that. We've got 100 million lines of code on the vehicle. And if you think some of the services and some of the things that you want today, off-board, away from the vehicle, navigation and these kinds of things, personalization, entertainment. So, and then when you get into controlling the vehicle, the autonomous kinds of capabilities, just so much software and so much code today.
Andreas, you have told us in our previous episode some of the folklore of the German automakers setting up facilities that looked like startup environments and sponsoring hackathons. Now it's all about the driver experience. Is that correct? Is that the main priority?
Yes, and obviously with respect to the commercial success, a driver experience needs to be wonderful, but for the OEMs, what is important is the change in terms of what are the influencing points for buying decision. And also that changed with software-defined vehicle architectures significantly, yeah. Because nowadays, when you look like at a market like China, but also in Europe and US, yeah, young purchasers, they look at electronics, they look at the capabilities, with respect to, having more or less an extended workplace, yeah, combined with autonomous driving in your automobile, yeah, having connectivity, yeah, with the kind of applications you have on your mobile phone, yeah. So having augmented reality in the heads-up display with the highest sophistication and with a user interface which needs to match experience you get on a smartphone. Those are actually very, very important factors for products coming out of the market to actually be successful, besides the classical, let's say, parameters and capabilities.
David, are the tastes of drivers different in Asia versus Europe versus the U.S.?
Well, let's take US first of all. America was built around the automobile, right? The dream and the road and everything through, the eras through the 50s, 60s, 70s. And car trends were driven by, from the muscle cars to when we had the boomers having many kids and the vans, and then into the utilitarian vehicles of SUVs and trucks, So I'd say America sort of went through that progression of the love of the vehicle, the love of the car, and then through that phase, and it's become a lot more utilitarian. I think in Asia, many triggers in the smaller countries in Asia, the smaller vehicles are needed, more utilitarian, the smaller streets and things like this. And then, the bigger countries in Asia just getting around and just owning a car. So I think the need drives more than anything else, I would say. And obviously Europe, you can look at Europe and beauty of the car, and then from the beauty of the car to the utilitarian need of the car, right? So I think it's different around the globe, and there's no one size fits all, but certainly we're moving into more utilitarian, and then utilitarian is moving to more personalizations. So you can imagine things like software that it's my car and my special things for my car.
Well, it's interesting because, I've heard about predictions that there will be a day where nobody owns their own car. They just use a car that happens to be handy to them. But the idea of stepping into a car and having a virtual desktop experience like I would stepping up to a PC that's connected to the cloud, you have that expectation of personalization that only software can deliver. Andy, how are automakers coping with this incredible amount of complexity and the pace of the increase of the complexity?
So the current, let's say, coping and to the challenge actually is needs to be improved, I would say. And there's no blaming on the industry. It's my view is that the automobile industry needs to look at industry like smartphone, mobile devices, yeah. And also look like what was essential there for having higher productivity in software development, higher quality, and shorter time to market. Yeah, and to my mind, the following things are coming up. At first, more standardized APIs, very strong separation of hardware and software application layer. Yeah, so the intermingling of hardware and software in place, easy use. That's not, let's say, possible anymore, and doesn't make sense. Yeah, and the third thing I would say also standardization in terms of OSs and certain middleware layers. Yeah, everything which is probably commodity. Yeah, needs to be built once and used by a lot of industry players, especially we got the numbers at 100 million, 200 million lines of code in a car. You're not going to build this whole stack again and again and again. Yeah, there needs to be a base stack which is not differentiating, which is shared amongst as many industry participants as possible. You get innovation, you get stability, you get reduced cost, and at top of it, you have this abstraction layer which allows you to build differentiating applications, which are giving some level of personalization, which might be linked to the brand, but also might be linked to the different personas and purchasing segments in the industry.
It's interesting when I think about this concept of separating hardware and software and creating open systems. I think way back to university days at AT&T Unix System 5.
Sure, yeah, yeah.
And you think about how all the major OEMs of computer hardware, particularly the mini computer days, created extensions to System 5 to make their open system just a little bit better and hence a little bit more proprietary. And I think about IBM AIX, for example. Are you seeing that same temptation coming to the hardware makers of automobiles wanting to make their open base just a little bit better?
Well, it's challenging, right? Andy just mentioned the amount of code that goes onto a vehicle. So there's this kind of dilemma you're dealing with. That if you look at the history from those first electronic systems that had some software on them in the late 60s through these decades, every time we needed a new feature and function, we just added a new computer, if you like, whether it's to do listen to the vehicle, what we call sensors, to do some calculations on the vehicle, the processors, the computers, or ECUs as we call them on the vehicle, or if you want to actuate something. No, I don't want to wind my window up and down. I need to have it electronically controlled, sunroofs or things all around the vehicle, to these 100 ECUs we have on the vehicle today. So do I do that all myself as a car maker, or where do I rely on? And then over the years, we used to buy that as what we call a black box, right? So you buy a computer that does the thing you want it to do, and that's gone out of hand. We can't afford that anymore. And if you can imagine moving into the world of robotic vehicles, automated vehicles, self-driven vehicles, the level of code we have today and the level of electronics today, we're moving into a tsunami of electronics and software. So we can't keep going down that route. So now the trend is to centralize, and I want to move it to a few computers on the vehicle. And that what Andy called an abstraction, the separation of the hardware and the software, is highly important. I want to choose where I put my software. Maybe all the things that are doing all the propulsion engine controls, I want somewhere, and I got to segregate it for security reasons and safety reasons, etc. And then other things for infotainment, and then we have these what we call domains, right? So now the automakers, they just can't ramp up to thousands and thousands and thousands of software engineers and electronics engineers. So they got to get more smarter, and they are getting more smarter. So now it's about how can I reuse things as we bring things. If I've got something as simple as on-off, right? How do I do that one time for whether it's a door or a radio or whatever it is, mapping. I don't need all that many times across the vehicle. So they're getting smarter, and they're separating that electronic piece from the software piece. And as we go through that, we'll see kind of a more the automakers themselves take more control of that kind of side of the business, right? They're no longer just making the beautiful car, but they're also taking control of what software do we want managing this vehicle, on board and off board, right? And think about all the things of where's my charging station for electric vehicle.
Andy, it's almost as though those automakers are becoming operating system makers and setting the standards for how, to create extensibility and to allow third parties to plug into that operating system predictably.
The operating system direction is still out there in, what's going to get evolved. Yeah. My personal prediction is there will be a consolidation. There will be a consolidation just because of the reasons, Dave, and I mentioned, like in terms of standards, a huge amount of code. You cannot have for all the OEMs their own OSs. That's just commercially doesn't make sense. Technically, it does not make sense. From a productivity innovation point of view, does not make sense. So my prediction is there will be a consolidation, probably with alliances, maybe some blocks building, and probably maybe not as intense as in the smartphone industry, but still lower amount of different OSs which will be shared amongst different industry players. That's for sure happening. The second, let's say in terms of infrastructure, we need with a software-defined vehicle, architecture, you have the need to update, also drivers, middleware layers, but also very often and frequently applications. So the whole infrastructure for doing this in a secure manner, to doing it such that which software version is out in which vehicle, in the hand of the consumers, practically. That is a capability where some players who started early, they are quite advanced. Some players are really catching up. But I see also, I have meetings with some OEMs, I'm not naming any regional name here, who are just at the beginning to think about it, what this all means. So, again, I would say probably the late followers, they probably will pick up, go with partners and say, look, we can get some of this competence from a tier one or with an alliance with another OEM in order to actually not having to reinvent the wheel completely.
Do you think that there'll be an Android and an iOS, equivalent in the auto industry?
I would say for sure the automakers want to know what's going on and off their vehicle. So they want control of that. So that's a necessity almost, right? So, and if you look at the regulations, things like the safety. So first and foremost, it's not like your phone. If the phone breaks, and we've all had it with smartphones, that's not a situation that the automakers can deal with. We're dealing with safety and people's health and the like. So safety, and then security, making sure people can't. You imagine the robotic vehicles of the future. People taking control of that. We've got to have complete control of the vehicles. So regulations are driving that in the markets. We're already seeing that with safety, security, and the updates. You see all the time with your smartphone, the phone's getting updates, and it doesn't matter if all of a sudden one of your applications doesn't work so well, and you go back to a previous version. So that's fine for things like smartphones, but on a vehicle, we have to be able to update it, and obviously over the air, right? So we've got to be able to update it over the air, and we can't afford the mistakes, right? Because of the safety and security. So the automakers have to stay in control of that vehicle, their vehicles. So I think it's obvious that they will look to maintain that control.
Stakes are higher.
Much higher. People's safety and security is at stake.
Andreas, when it came to privacy, the EU really led the way for the world in setting up a regulatory framework to assure protection of private information for people. Is Europe also leading the way, creating frameworks for safety and privacy on these vehicles?
I would say generally in terms of overall, sensibility, it's probably the most, let's say, sensible market globally when you look at, let's say, the large three blocks like Asia, US, and Europe. And that has pros and cons. From a consumer point of view, this is certainly welcome, because as a consumer, you want to know, like if somebody is tracing where you go with your automobile and what kind of, purchases you probably do at which parking lots in front of Walmart. That's quite sensible. And as we know, especially with artificial intelligence, the analyzing of this kind of data is getting to get much more. And therefore, I would say, from a European point of view, we need to find a good balance between protecting consumer, but also avoiding that innovation gets killed down and all the innovation goes to other, let's say, larger market blocks, because it's just too restrictive in Europe. Yeah, I would say there's a possibility to find compromises, but it requires in a democratic society, it requires iterations with the stakeholders. You need to find agreements. You need to find the right balance. It's probably happening. It's happening in Europe. The restrictive side is sometimes too fast. Yeah, and my prediction is it's going to be a little bit like a pendulum. Yeah, it's going to be probably too restrictive, and then the industry will, with the lawmakers, will help to actually get it into the right center, the pendulum. Yeah, so that all the stakeholders are happy. That's my partially personal view. The final thought here: we must construct it such that it's not, let's say, hindering innovation and all the great bright brains are going to other things.
Let me change gears for a minute, if you can just forgive the pun. I know that's terrible. We talked about the complexity avalanche. And in fact, the Technology Services Industry Association wrote a book by that name 15 or 20 years ago. And it was promptly followed up by another book called Consumption Economics. What are you predicting in terms of the new commercial models and the ways that people will create value and consume value, recognize and retain value when it comes to the automotive industry?
Well, the old model in automotive was you had the car makers themselves, what we call the OEMs, the original equipment manufacturers, and then you had this tiered structure of suppliers. And if you look at the tech world, right, you've got all the technology companies, the guys that make your phones, people that put all that cloud technology in front of you, your shopping systems, etc. That's becoming really cloudy, right?
I'll forgive your pun as well.
Very cloudy first, right?
Yes,
as we say. First. So that's becoming so it's converging, right? So you can't just be the car maker. You can't just be the electronic device maker anymore. So that world is gone, right? So they have to reinvent themselves, right? So for the last number of years, a lot of our work has been in and around that transformation space, right? So they've got to reinvent themselves. Are you still a specialized car maker or a large volume car maker, or where do you fit into the equation? You look at personal use vehicles versus, think about all the lift share and the shared use vehicle kind of models that are out there. So we're going through that reinvention phase, right? So for me, it's kind of a difficult question to answer, but we know the technology on board and off board is accelerating so fast. Artificial intelligence is coming towards both on board and off board, and people are having to reinvent and decide where they want to play in that game. People that weren't necessarily car makers might be car makers, and car makers might necessarily be car makers. Specifically, they might be integrators, system of systems, etc. So it's a new world out there.
Andy, David just mentioned this notion of a system of system. I'm picturing emerging suppliers to the OEMs, the tier ones and the tier twos, almost like gangly teenagers trying to wrap their hands around how to deliver software in a tidy package when they've probably got a lot of sprawl and messiness underneath the hood. How are the OEMs wrangling that sprawl of complexity, and how are they managing these discrete systems with some sort of an overarching point of view on how things are going?
I would say still it's a certain amount of divide and conquer in order to manage the complexity on a system level. You have architecture and you have a system of systems. Yeah, and this in a software-defined vehicle scenario and architecture scope. Yes, the architecture looks very different, and the value generation is different, and they probably, as also discussed in the previous episode, the way components or systems or subsystems are delivered is different. Yeah, it will be not a black box with the ECU and kind of a real-time operating system connected to sensors and actuators. It will be much more, let's say, open and transparent. Yeah, and I would say the difference is that the OEMs will still collaborate very closely with the tier ones, but it will be a different way of collaboration. Yeah, there will be more transparency and openness and access to the, let's say, to the application, to the code. Yeah, there will be joint agreements about IP development, which will be leveraged amongst both partners with an OEM and a strategic tier one. Yeah. And some of the drivers of the collaborations is actually in cost. Yeah. So we have the number of lines of code and the complexity. The industry needs to find a way to reduce cost. Yeah. And one way to reduce cost is obviously to work smarter, more efficiently, but also to share the result of an investment. Yeah. Because that allows you to actually get the investment paid back by more sold cars. Yeah. When it's shared. Yeah. So those are my high level observations. Yeah. In terms of digitalization, one thought for some very, let's say, mechanical players, there will be the question, looking at the software-defined vehicle architecture, where is there a way for electronics? Is there a way for electronic or software, let's say, enhanced value? Yeah. I see this a lot also with tier ones where they say, let's pick the example like e-drives. Yeah, there is an e-drive instead of a combustion engine. For electric motors on the front and the back wheels very often. And then there's obviously the control of the e-drive, which is communicating with a computing unit. As they've said. But there's lots of software also which is actually managing those e-drives. Yeah. So there is a way, obviously, for digitalization, for software capabilities, yeah, and it's linked to the complete system. But what is the but? Those players need to build up new electronics/software capabilities, yeah, and that means this cultural transformation, building up competences which are able to actually make a difference in the market, which are competitive, yeah. And which are innovative, yeah, and this is the way I see it working out, yeah. Some players will move fast, some players will hit the need of the markets, some other players will be delayed, and there will be probably consolidation.
David, car makers are facing this twin needs for faster software development and shorter development cycles. Against those odds, how are they assuring that they get good quality in the software that the teams are creating?
They've got a challenge on their hands. So we always talk about agility, right? So they've got to do things much, much quicker. But there's that large complexity of software. So how do I keep the robustness in there, right? So you can imagine all the thousands of people that are interacting. So we need ways, operating models and the likes, to make sure, whether they're part of your company or other companies, part of the ecosystem of partners that work together, we need technology that helps them collaborate and the like. So there's a huge amount of just the how do we collaborate in the work we do, and then there's the collaboration in terms of the technology, the technical aspects of it. How do I keep the traceability between all the top level vehicle kinds of things, onboard, offboard? So traceability is a very key, and technology plays a big part in that. So they're investing heavily, especially the forerunners and the leaders, into a new way to ensure they're resilient against all the vulnerabilities and challenges that they face, the cybersecurity and safety challenges. So it's partly operating model, and it's partly organization structure, and it's partly technology.
Well, you and Andy are friends in the industry, but Accenture has selected Codebeamer as a platform to help many of your clients get a handle on those twin needs for speed, faster cycles, reducing defects. Talk a little bit about how you guys are using Codebeamer in the field.
Well, one of its first capabilities is the traceability side of it. So a lot of the OEMs and the people that make all the electronics and software that go behind that, they have to have the traceability. So big play on the Codebeamer side of it is its ability to handle vast amount of data with high levels of traceability. So that's where we came into the game. What we are dealing with is all the organizations that collaborate together and the like. So that's where the Codebeamer side of it comes into play. So the people that are picking up on that and running with that, the old ways of working, the old tool chain that we used to use in product development, it just doesn't suffice anymore. We're not making mechanical machines anymore. We're making very sophisticated electronic and software automated machines. And that takes a new level of technology. And that's really where Codebeamer comes into play.
We use the term traceability as common parlance, but it may not be something that that a finance person would understand. What do you mean exactly by traceability?
Yeah, good question. So you can imagine we start with the customer, right? What does a user of a vehicle want, or someone that interacts with a vehicle, whether it's a technician or a mechanic? There's lots of different roles, right? But mainly the drivers or the passengers, the users of the vehicle. So what are their needs? And then how do I translate that needs into everything that's technically in all the systems of the vehicle? And we have to trace that down to the engine or the propulsion systems, to the infotainment systems, to the navigation and all the connectivity, we have telematics systems on the vehicle. They're all interacting all the time across various network systems that we use both on the vehicle and off the vehicle. So when we talk about traceability, we're tracing from the originating request of the user all the way through to the lowest level, call it the part or the line of code, and making sure that we have also verified and validated that that's the right line of code or that's the right lowest level component. That's what we mean by traceability.
So for OEMs who went from maybe thousands of physical parts in an automobile to now millions of lines of code, they really need a purpose-built software tool to manage that complexity.
Exactly. Like we have call it a database that used to control 20, 30,000 parts, hardware, physical parts on a vehicle. That thing then to millions and millions of interacting systems. It's a new game that we're dealing with, right? A whole new magnitude of interaction that's going on.
So, Andy, Codebeamer is that fit-for-purpose tool?
Yes, absolutely. However, I would like to augment and make a strong recommendation here. We need to speed up software development in automotive. It's actually interesting word to speed up, right? In automotive, yeah. And the reasons for speeding up is, as we discussed, more value, faster, lower cost, higher productivity, yeah. And my recommendation is that we really combine those fit-for-purpose tools like Codebeamer, yeah, with industry-proven enterprise, yeah. And this is the setup we see very strongly in the industry. We tools from Microsoft like GitHub running on Microsoft Azure cloud, yeah, and the testing tools which are used also in enterprise. But this is combined with Codebeamer, and I would like to use a metaphor. Yeah, it's just like we want to drive as fast as possible on the highway. Classical enterprise development also with top quality requirements and everything, and user interface, other user interfaces. In automotive, you have additional requirements as we discussed. Yeah. So the difference is you want to drive fast on the highway. Probably there are a little bit more limitations, there are a little bit more science on that journey. Yeah. And Codebeamer is kind of giving certain science or boundaries. Yeah. Codebeamer makes sure that you fulfill certain process, prerequisites, yeah, quality prerequisites, which you probably don't need in an enterprise setup. Yeah. But again, the key message is in order to move up productivity in automotive grade software development, we need to combine both. So, very well working tools and infrastructure from enterprise software development with fit for purpose tool stack.
So it's really a team sport.
It's really these, and maybe one more thought on that, just to augment, since we are also really strategizing this with Accenture. One initiative we have going together is, compared to a Fed development client 15 years ago, where you had a lot of development tools, all the complex development tools, and as it is possible now, this is into the cloud. Yeah, so the advantage of a cloud is you can already pre-configure the complete development infrastructure as long as all those tools you need are cloudified. Yeah, and you have a much faster, ready to go setup. Yeah, I think Shomit mentioned it. The cloud allows you to actually simulate an ARM or Intel architecture. Yeah? So the advantage of such a setup is even before the hardware is physically available, you have abstraction layers. You have either the cloud, let's say ARM-based or Intel-based, but you can already in an agile manner develop your applications even before develop, test, and get feedback on the application even before actually the physical ECU is available. Yeah? And that is kind of partially a shift left initiative. Yeah. And again, Accenture and PTC, we are driving forward some initiatives in order to, have such, example or best practice configurations for, I call it a software-defined, cloudified tool chain, ready to go in an instant. Yeah. Okay.
And I think if you look at Europe, you've had the advantage in places like Germany where you've had no speed limitation, whereas we're kind of speed limited here in the US, right? Especially if you have some of those fast cars. But when it comes to cloud, we're not speed limited, right? So that's where we come into play. We can put the pedal down and accelerate on cloud-based capabilities.
Well, it's a wonderful tee-up for our next conversation, I think, Andy. We're going to have one of your colleagues, Amar Bhardwaj, is an expert on systems of systems, and he has a very strong point of view informed by his role as the software-defined vehicles lead for North America with Accenture Industry X. He's going to come and talk to us about the transformations that he's seeing and his prediction that there is going to be a need for an abstraction layer to help the leaders of auto companies understand the progress and drive faster productivity through myriad suppliers of software from their tier 1, tier 2, and other contributors. David, I want to thank you for being with us. Just a pleasure.
Thanks for having us. Yeah.
And Andy, I'll see you next time.
Yes. See you. Yeah. Thanks. And Dave, thanks for being with us as well. It was nice.
Yeah. Looking forward to seeing you soon again.
Yeah.